welcome to Hardware Meetup Innovation in AgriTech. I'm your host, Michaela Stokes. So could you put up your hand if you've been to a hardware meetup before? Okay, it's about half, that's pretty good. So for those of you who haven't been, we've been running since 2016 and we're all about bringing people together to showcase amazing companies working in different areas of the hardware space. Okay, so for the event layout, we have 3 speakers. Each of them will be half an hour each with 15 minutes of kind of talking with me and then 15 minutes of questions with you, the audience. Halfway through, so after our second speaker, you will have the chance for 1 minute to come up and pitch. You might have a really cool idea that you want to talk about and get some opinions on. You might be looking for a job. You might be looking to hire someone, those kind of things. So 1 minute each. So when that break happens for 15 minutes, come and line up over here and talk to me. Cool. So we couldn't do this event without our amazing sponsors, and we're really lucky to have 3 today. So first up, we have Loon Digital, an expert engineering team helping you to develop smart, energy-efficient IoT devices. And here we have Edith with us here today. Wave, Edith. Hello. So come have a chat with her. We have Blackbird Ventures, which aims to invest in the most ambitious Kiwi startups. If you're interested in chatting to someone about what you're building, reach out to them online, yes. And then last of all, we have Hudson Gavin Martin, which is a corporate, commercial and dispute resolution law firm boasting the largest and most experienced legal team in the country, focused on technology, media and IP. And last of all, we actually do have a 4th sponsor, which is Outset Ventures, who we are so lucky to be able to use their amazing venue that we're all at today, which is the largest deep tech co-working space in New Zealand. They're always on the lookout for new companies to move in. So if anyone is interested in desk space or wants to learn more about Outset, you can come talk to David over here tonight. Here we have Andrew, who is VP of Platform at Halter. Andrew, can you tell us a bit about what Halter does?
Yeah, so I guess Halter aims to make farms more productive and sustainable, and currently we do that through precision virtual fencing. So that involves a collar, tower, and an app. I can kind of run through what they do, but essentially we aim to for all of our farmers to grow and harvest more grass. Dairy farms are inherently very limited by fences and labour, and so virtual fencing and our collars allow farmers to basically remove those traditional constraints and run more mobs, remove fences, and very efficiently graze their pasture, essentially. So there's 3 components to this. The first is a collar. This is kind of the thing we spend a lot of our time on in the hardware side of Halter, solar powered. It's LoRa, Bluetooth, Wi-Fi, all of these fun things, and it kind of acts as a shepherd for every individual cow, and the cows go through a training phase to understand their collar, and it guides them around. The second is a tower. So every farm we figure out the topology, we drone map the farm, we do some RF modelling to understand the best placement for each of the towers, and then we essentially run a local network on the farm and provide 100% coverage to any of the collars. And so we're constantly communicating back and forth between the towers, they mesh and then backhaul to get all the data off the farm. And then the last part, which the farmers see, which the customers interact with, is our app as well. And so we do a lot of data stuff to every single day. The farmer automatically gets their average pasture cover updated in the app, so they understand exactly how much pasture they have at any given time. We run heat and health models continuously, and they set and move the cows through the app as well. So that's kind of the interface. Those are the 3 biggest components that make the Halter product work.
Awesome. Can you tell us a bit about how your products are made and how they work, kind of?
Yeah, so I imagine I might get some questions on this stuff. This is a kind of a summary slide. Everything that we do is in China. All of our supply chain's in China. The expertise is in China. All of our team has visas for China, and it's amazing. You can New Zealand unfortunately can't really compete super well on a lot of this stuff. And so we have a setup where we have a contract manufacturer. They do all our electronics assembly, SMT, final testing, all of that. And then for custom stuff, mechanical parts, batteries, solar panels, all that kind of stuff, we have Halter controlled suppliers that we work with super closely. Yeah.
What has the journey looked like so far?
Pretty hard to summarise, a long period of time, but I figured I was keen to just chat through some stories and various things of what it's looked like over time. I think one of the things that's definitely true in all startups is you come across heaps of problems and challenges, and that's kind of constant. The problems change, and how you solve them might change, but they're definitely constant, which has been one of my highlights at Halter. This is one of our very first collars. This was on our R&D farm in the Waikato. All of these collars, we made 50 of them. They all snapped in half. They weren't waterproof. The solar panels didn't really work. So we learned a lot from those. And we it took about 2 months to design, a month to build them all. And we very, very quickly just moved on to the next iteration. So that was like early days.
When was early days?
It's like 2018, maybe 6 months after like the seed funding.
Wow.
So yeah, we very quickly learned some of the very core challenges that we still grapple with, I would say. This was the first collar off the production line in China. We built 250 of these collars, proper mass produced. Well, 250 not really mass produced, but injection molded parts, proper SMT, and we had to manually die grind every single solar panel recess because the parts shrank, and we did that for 2 days straight just to get the build done and the collar shipped back to New Zealand. I think we definitely have a theme of kind of doing things that are very fast but not necessarily efficient. Like sometimes it's way more important to do the hard things even though they suck. That was pretty good memory. This is our first commercial farm install. It took us, this is James who's here tonight, in a hole that we dug by hand. We hand mixed like 200 bags of concrete. I think it cost us $100,000 to install the farm. Took us probably a week. Like that doesn't even factor in the people time. It was super, super intensive and manual, but we got it stood up in 2 weeks. And now the towers that we have are installed by 20 minutes by the farmer. But you can't, I guess this is the same theme of like, but that project to make those towers took 6 months. We didn't have 6 months here, so you just like brute force it to get it done. And now it's just a lot more seamless. Yeah, that's kind of the things that I wanted to chat about.
Awesome. And what's the future looking like? What are you guys pushing towards?
So I guess that's the slide. Our vision is to unlock 50% of the world's land mass to be more productive and sustainable. And so 50% of the world that's habitable is used for agriculture of some kind. We're obviously like very focused on livestock, and that'll continue to be the focus for a while. I think at the moment we've got a lot of farms in New Zealand and Australia. We're looking elsewhere. There's a lot of cows. There's 1.5 billion cows in the world. New Zealand has 11 million. So we got a lot of cows to go. That's one side, like taking that global. And then I think as well, 50% of the world being in ag, a lot of that isn't cattle. There's horticulture, there's arable crops, there's like a lot of things there. And the size and scale Halter is now and the expertise we have in-house is pretty cool, where we have hardware, we have production, we have a lot of like data, a lot of software capability, and so it's very, very exciting for what we could do in other verticals as well. Yeah, but many cows to go. Yeah.
And is there anything that the audience can help you out with today?
Yeah, so Halter is hiring at the moment. So I just took screenshots from the website. We got electronics roles, we got mechanical roles, production roles. There's actually more production roles than just on there. We got software roles, kind of across the engineering spectrum, to be honest. So we also have a little category that says just anyone epic. Like if you just back yourself and think you're epic, then historically we've found places for really good people. So that's probably the number one way. If you know someone that's really happy where they are, but they're epic, then we're also happy to chat to them. So that's probably the main way. Yeah.
Awesome. Thank you, Andrew. So now we will open up to questions from the audience.
Thank you for the intro. You talked about sustainability, and I'm curious to know what happens to the collars when the cows go to the processing plants?
Yeah, so we are largely dairy, so those cows have a very much longer lifespan than beef. But any of these operations will continue to use the collar. So if a cow is culled, which is part of the farming system, they'll put that. They need another cow to produce milk or another cow to make beef, so they reuse the collars.
I'm just curious with your comment about going away from, well, not going away from cows, but exploring beyond cows as well. Was that a decision driven from the sort of move towards sustainability with dairy herds having pressure to be decreased, or is that just your technology that you designed for your existing collar sort of lended itself to actually be further developed naturally for other uses?
Yeah, I think that's probably still a very like blue sky type arena for us. I wouldn't say that there's key strategy for the next 5 years on exactly what we're going to do there. I think a lot of New Zealand dairy is actually like one of the most advanced, most efficient forms of ag in the world. We use like our land very efficiently because there's no subsidies. It has to be efficient, and so many other parts of the world there's like huge theoretical gains to be made on but they're fundamentally limited by the same things that New Zealand dairy are, whether it's like fences or labour or a lot of these things. So I think it's like the fundamental limits for those types of ag are very similar to what the limits are in New Zealand dairy. So there's huge amounts to be unlocked and gained as like a general principle, I'd say. Exactly what that looks like, don't know yet.
Exciting, cheers.
What are the backhaul networks currently you are operating? Just Wi-Fi and Bluetooth, or even kind of backhaul network is LoRa, Zigbee, even GSM, like all these in the scope, or as on today, what exactly is a backhaul network?
Yeah, so between collars and towers, we use LoRa.
Okay.
That's used for 99.99% of all comms.
Okay.
From the farm out, we largely use 4G, but in some cases we'll use just an internet service provider of some kind. We can use Starlink, like a bunch of those generic options, and then the towers communicate over a Wi-Fi mesh.
Okay, and is there any, again, I'm not sure, there will be a lot of data analysis we'll be doing. Even the cow, even the cows, or even the, basically, like, are you monitoring the health of that? You are monitoring the health?
Yep, so we look at the behaviours of the animal, so we understand when they're grazing, resting, ruminating, walking, and then we kind of make a lot of decisions based on how those things change over time. Often if an animal is sick or there's something wrong, even if it's hard to tell exactly what, if she goes from 600 minutes of rumination a day and that falls off a cliff, there's usually something wrong. So it's like eyes on all the time.
Okay, thank you.
Hey, I enjoyed the talk. Forgive me if I'm missing something like obvious, but how exactly do you estimate pasture cover on the farm?
So we use a whole bunch of inputs. I guess on a farm, the grass grows like in a sigmoid curve, and when you do nothing to it and you get sunlight and there's a certain temperature and moisture, the grass grows quite predictably. And so if you just do nothing, the grass on your lawn, the grass on a farm, it just grows on like quite a predictable level. And so then when you graze it or you have some interaction with the cow, that changes it like quite quickly. So it's a bit of a sawtooth. Right. We basically have big neural nets that take in satellite data and then a lot of like environmental data as well and spit out estimates. And then farmers can put in manual entries. So we have this like live feedback loop running to estimate that. But it's super important. Like a farmer, imagine trying to make good decisions on your pasture and you have no data. Like half our farmers don't know how much pasture they have, or they look at a paddock and they're like, roughly this.
She'll be right.
Yeah, she'll be right. But now they have like pasture cover for every like 3 by 3 meter square. So you know exactly how much how many kilograms of dry matter across your entire farm. So we're taking like what was an art, making it more of a science.
Epic.
G'day. Just wondering, have you had any challenges around either regulatory requirements or skepticism or distrust within the industry?
Yeah, in Australia, for example, there's some states where any kind of like electric collar is outlawed. These are like really old regulations, 20 years old, and they're kind of all being reviewed at the moment. And then we have like a lot of pressure from farmers in Australia on the regulatory bodies to essentially allow it. So that's an example of a challenge we've faced. I think the biggest challenge for us has been education on like an external level of understanding. Is usually we're still astonished by like how little people know and how much they decide based on like just the very first kind of assumptions. So it's all like an education game, and actually we often invite people to our farms, like live customer farms, so we can educate them and show them what's happening and how it works, and that always like goes really, really well. So it's an education game, I think.
We have Kiara, who is a senior R&D scientist with Daisy Lab, and I was very lucky to be able to talk to her today, and it sounds so cool. So I'm very excited to share this all with you.
Thank you for having me.
Cool. So could you tell us a bit about what Daisy Lab does?
So Daisy Lab is in the business of making cow's milk proteins without the cow. We're sort of somewhere in between traditional dairy and alternative dairy because we use a technology called precision fermentation to produce dairy proteins that are molecularly identical to what you would find in a cow. We take yeast cells, like the cells that would be used to make bread or wine or beer, sort of similar yeast cells, and we genetically engineer them to make cow's milk proteins instead. And then we can filter those proteins out of our fermentation soup and use them to make food ingredients, or as food ingredients to make food products like ice cream, yogurt, cheese, etc. And when I say proteins, what exactly do I mean? Well, if milk is 87% water, there is this 13% that is solids, and that's all of your fats, your sugars, your proteins. In the protein category, there's two subcategories. There's casein, which is what's used to make cheese, and that's what coagulates to make cheese, and that's what gives cheese its stretch, its texture, its flavor. And then when you make cheese, you curdle milk, you separate the casein from the whey.
Rain is
Sorry, I'm going to do my best to compete with the rain, but it's loud. People in the back, can you kind of hear me? Yeah? I got some thumbs up and some so-sos. Okay, I'll use my outdoor voice. So you separate out the casein, and what you're left with is whey protein. And whey protein is still really important for food products. Should I just wait a second?
I don't think it's going to go away. You guys can hear okay, right? Yeah, I think you're right.
So what's left is the whey proteins. Whey proteins are still really important for making food products, your liquid food formulations, so yogurt, ice cream, cream cheese, things like that. Some of those weren't liquids. And then also within the whey category, so the most abundant whey protein is beta-lactoglobulin. And then there's several more rare whey proteins, such as alpha-lactalbumin or lactoferrin, that are really high value proteins because of their health benefits for the immune system and or for transporting things like iron in your blood. So those are the four classes of proteins that we are working on producing at Daisy Lab. And the reason we're doing this is the potential impact for the environment. So this technology has the potential to reduce land use by up to 99%, water use by up to 97%, and reduce greenhouse gas emissions by up to 97% as well. And I'll just speak a little bit to the greenhouse gas emissions side. Dairy is a massive polluter, but not only to our lands and our waterways, also when it comes to greenhouse gas emissions. So 2.5 billion tons of greenhouse gas emissions are produced by dairy annually, and that's a staggering 5% of global greenhouse gas emissions. In New Zealand, where dairy is our biggest exporter, and actually the biggest exporter is dairy protein powder, or dairy powder, whole milk powder specifically. And in New Zealand, dairy contributes nearly a quarter of New Zealand's greenhouse gases every year. So the goal of this technology is to sort of offset that and continue to meet demand, which is only continuing to grow, especially in markets like China, et cetera, while not increasing our footprint.
Yeah, awesome. So how exactly do you make these proteins?
Good question, and I can't reveal all our secrets.
Damn.
But our process can be split into two components: the upstream, which is your production and collection, and the downstream, which is really all of your processing. So that's filtration, spray drying, and reformulation. Only we replace the cow with yeast cells and fermenters. And a big advantage to our specific technology is, we're growing up these yeast cells in big fermenters, and our protein is being secreted directly into that broth. So we can then take our broth and put it through exactly all the same downstream processing equipment that already exists for dairy. That's massive for us because precision fermentation products usually up to 70% of the cost of production is this downstream step. So by making something that's compatible with existing technology, one, it'll help our rollout, and two, it's gonna slash our costs. So that's really exciting. And I'll go into these steps in a little bit more detail. So first, we genetically engineer our yeast, and that's what I do on a daily basis. So that's essentially taking genes from the cow, so the genes that code for the cow's dairy protein, whichever protein that may be, and putting it into our yeast cells alongside the genetic instructions to actually make that protein. And then we ask it very kindly to make it, and we're constantly comparing iterations, so throwing more things in. There's a lot that we can do with synthetic biology tools, genetic engineering tools. So the strain development is always ongoing, but once we have our champion strains, so strains that have really high yields, we move into fermentation. Currently, we're at lab scale, so we've got like 1 to 3 liter fermenters, and then 10 liter fermenters, and a 7 liter stainless steel fermenter. But at scale, this would be first in pilot scale, it would be 2,000 liters. And then at scale, we'd be talking 100,000 liter fermenters sort of thing. But this increases our yields. So we've developed protocols that increase our yields a further up to 15 times. Which is awesome and a massive achievement for us. One of our scientists has a lot of experience in fermentation. We did not know this when he was hired. So that's amazing.
That's a nice surprise.
Like he taught it, like it's a great surprise. And then also this is our scaling. And once we have our broth, we would then move into filtration. So that's separating out our proteins. And again, that's using the same equipment that dairy traditionally uses.
So at this point, it's the equivalent of giving the dairy industry milk, and then they go do whatever they want with it, basically.
There's sort of one step that we have to do a little more rigorously than dairy, and that's separate out all our cells. But they also do that. They also have to control for microbial growth. So essentially this is all the same as it would be for processing milk. We filter out, and we're blessed to have access to all the world-class equipment in New Zealand. And then we would spray dry. So then you've got physical protein powder, which we would then work with partners to turn into food formulations. So that's a bit about our process and what it actually looks like step by step.
So wait, so let me get this right. So basically, you get the equivalent of milk, which is actually vegan because it doesn't actually have any,
No cow start to finish, no animal, derived products.
but it's still milk. Okay.
Yeah. Real milk
Right.
without the cow. Well, real milk
Proteins.
without the cow.
Yes, and then because all this like filtration and spray drying, all that already exists like in the dairy industry, so you're just reusing all that equipment.
Correct. Yeah. Which massively simplifies things for us and is sort of one of our competitive advantages.
So all you need to do is make the cool protein soup.
Yes, protein soup is my business. Yeah.
So what does the journey look like so far for Daisy Lab?
It's been a big one. So we were founded in 2021 by these three awesome female co-founders. Irina and Nikki Fried were our CEO and CSO. And then Emily McIsaac has since taken on a lot of operations and financial responsibilities in the company. But initially, she was a master's student in the lab trying to make this dream into a reality. And she sort of laid a lot of the groundwork for myself and Daniel to come on in early 2022. And in the first 6 months of being there, we went from this sort of still entirely being theory and not really knowing if we could achieve it, to producing several proteins across several organisms. So that was really exciting. And this photo is an example of one of our first gels. So this is our chemical proof that we'd done it. There was nothing tasteable, there was nothing tangible. It was chemical proof. No.
No laser pointer today.
Oh. Yeah. So this band here, what this is it's a SDS page gel, and you load your protein samples in the different wells, and then run electric current through it. It separates by size, and then you stain the protein. So these three bands are examples of some of our first ever produced whey protein. And at this stage, we were making like 50 to 150 milligrams per liter, which was pretty tiny. And over the next year and a half, we got to more than 1 gram per liter lab scale, which was a massive accomplishment. And then we also have hired 2 additional R&D scientists. That's Bhavesh Govind and Nick McGrath. And we had, good enough yields that we could move into fermentation. So we did our first fermentation trials with Callahan Innovation, and then we moved to Outset. We invested in our own lab equipment. We invested in our own fermentation equipment. We developed protocols for fermentation. We invested in downstream processing equipment. We developed protocols for downstream processing equipment. And finally, we were able to bring our first sort of concentrated soup over to Callahan for freeze drying for the first time. And then we had our first tangible, pure protein powder. And that was a massive achievement for us. And since then, we've produced a whole bunch more to make our first food formulations. So we partnered with several artisan cheesemakers and Giappo, the ice cream company, and we made several cheeses and ice cream and yogurt using our whey protein. So that's sort of from the beginning through to now how far we've come, and it's pretty exciting.
That is so impressive. Oh my gosh. I love cheese.
And they were delicious. In my non-biased opinion. It was incredibly gratifying, right? Like you toil in the lab for 2 years, and then you actually have something to taste.
Yeah, tangible thing.
And we had this big investor event, and everyone was just so excited about it. So it was really inspiring to see that too. Yeah.
And what are you guys pushing towards then?
Yeah, so
What's your future like?
We are hoping to, essentially our whole goal is partnering with dairy to reduce greenhouse gas emissions, reduce emissions while meeting global demand, right? And what that process looks like, we've done our lab phase. We currently have whey protein, the beta-lactoglobulin whey protein, ready for scale-up. We've reached high enough yields for scale-up. We've got several other proteins that we're still working on in the background in the lab, and we're always improving yields of that whey protein as well. But really now we're ready for our pilot plant. So this year is trying to raise so that we can build out a pilot plant. And we've just gotten EPA approval for scaling up to pilot plant production, which is massive. It's no longer like this thing we hope we'll get. It's this thing we have, and now we can do it. We just need the money.
That's awesome.
So we're raising, and then we'll build out our pilot plant. Hopefully we'll secure the regulatory approvals to go even bigger after that. And then we will have our Series A, and we kind of have a split in the road where we can take the technology and IP partnership strategy. So that's like licensing out our technology to companies and dairy companies potentially all over the world. And that would get us generating revenue pretty quickly. Or we can go the commercial plant route and build out our own plant and start mass producing protein powder that we can sell and collaborate with people to make food products.
Awesome. So from what I understand, so this is creating like, you can make powdered things. So this doesn't necessarily like replace like fresh milk or like, like fresh cheese or whatever. It just, you can use the powders in ways that the dairy industry normally would.
Yeah. So New Zealand's dairy industry, 95% of the milk that's produced is dried and shipped off overseas as powder. So that's sort of part of the market that we're trying to target. But then also a lot of the dairy is broken down into its constitutive parts for these high value proteins. And that's another thing that like this technology is uniquely suited to sort of target because we can produce one at a time. Yeah. Right. With a lot less resources. So milk is this complex thing that honestly tastes pretty good coming from the cow, but we could sort of help offset where there's protein powder being shipped overseas and where there's protein being extracted from whole milk.
And like how much, like it uses, like in terms of, you had the slide earlier, it uses like 99% less water? What was that?
99% less land.
Land,
yeah.
yeah.
97% less water.
Yeah.
Yeah.
That's amazing, yeah.
Up to.
Yeah.
We've yet to run like our own studies, but yeah.
Awesome. So yeah, for making specific things, it's so nice that you can just go straight to it rather than have to use all those resources.
For sure. And then, like casein's the biggest protein in cheese. It's the backbone of cheese, right? We can hopefully make that at scale and produce vegan cheese that is real dairy.
Yeah.
And beta-lactoglobulin and whey protein, like we've already played around with putting that in a few products, and it did change the texture and it did change the flavor profile in ways that are really favorable. So it can also be used as an ingredient, but not just like in your traditional dairy products, right? We could also put it in cookies, right? Protein cookies, like any product. So many products have milk powder in them.
Yep.
So yeah. There's a lot of opportunity.
Sweet. And last of all, is there anything that the audience can help you out with?
You guys can help us spread the word. So we've got all the social media channels, Instagram, TikTok, etc. And we're really just trying to push the technology forward and get the word out. And of course, we're also looking for investors right now. So help us out.
Awesome. Thank you so much. Okay.
Thank you.
Now,
Cheers.
now we will open the floor to questions. Oh, we've got an online question.
All right. So this is from Calvin. How do they overcome food safety regulations, FDA, and so on?
Well, we haven't had to fully yet. The current regulatory hurdle that we've just gotten over is our approval to scale up the technology to 5,000 liters. So we can do 2,000 liters per vessel and up to 5,000 liters total. But then on the consumption side, one of the benefits to our technology is we're filtering out all of the GMOs. So what's left is pure protein that is molecularly identical to cow's milk protein, which is already widely sold. So theoretically, all we really have to do is prove that our protein is identical, and that path should be a pretty clear one forward. But we also use something that's called GRAS organisms. So those are generally recognized as safe for consumption by the FDA. And likely there will be like GRAS applications in our future as well.
I actually come from a farming background myself, so I've been brought up on a dairy farm and that sort of thing. What's going to happen to our poor farmers?
You know, that's a good question. It's maybe not the most comfortable question, but it's a good question. I think this technology is something that would be sort of phased in, right? But also there is sort of a need in dairy farming for something like this. Like demand is just continuing to increase, and we can't keep increasing our emissions, right? So there is this gap that needs to be filled, and we're sort of hoping to start there, start with the more ecologically conscious consumers. And then there's also a production curve in dairy where you have insemination and they have their and so there's this production curve where production drops at times, right? And how can we help flatten that curve so that it's more sustainable as well?
So can work alongside pretty much.
Yeah, we're trying to be an and technology. Yeah.
Hi, I saw that you had a number of different milk proteins to be made. Do you have a vat of one specific strain of yeast to make one, and then a different vat and then you combine it in the right ratio at the end? Or do all these yeasts happily exist in the one tank, or is that secret sauce?
I think that's a little bit of secret sauce.
Okay.
Yeah, I don't know if I can fully answer that question. Sorry. Both are possible.
Very cool presentation. I'm curious to know if a competitor got hold of some protein soup, would they be able to sort of figure out how you've done it, or is it a bit harder than that?
It would be incredibly hard. So if they got hold of the strain itself, it would be easier because theoretically they could sequence it and work backwards. But if they just got a hold of like the protein itself, there is no trace of the organism that made it, right? So yes and no, but also just on the genetic engineering side, biology is a numbers game, and what we've gotten to, frankly, requires a lot of luck, right? Like, yes, planning will take you so far, and then there is this component of a lot of luck. So it's very hard to reproduce some of the, big leaps that we've had that have sort of just come from chance. Yeah.
Just a comment more than a question. Great that you've identified the reduction in greenhouse gases. I would also encourage you to talk about nutrient enrichment in terms of dairying and its impacts on the environment as well, because on that metric you can claim 100% reduction, and that would bolster your sustainability claims quite significantly, I think.
Thank you. Acknowledged. We do not have effluent runoff.
It's great to see such an ethical approach to dairy. Would you look at adding any additional amino acids or fortification as part of the process to make it even better than milk?
That's something that we definitely can look at down the line. Initially, kind of from the regulatory standpoint, it's easiest to just mimic what already exists. But like some people are allergic. If you're allergic to lactose, this is a lactose-free process. There's no lactose sugar in our process. But if you're allergic to the dairy protein itself, there's things that we could maybe do to play around with that allergenicity, or other properties of the protein itself. Yeah.
Oh, so if someone's lactose intolerant, they can still eat it.
Yep.
Cool.
As long as no one else adds any lactose in.
Sneaky.
Thank you. As you're now moving to scale up, what are the technical risks or uncertainties that you have, the unknowns around how your organism's going to perform and how it'll be grown at larger and larger scales? And are any of those unique to what you're doing, or are they just general, that's what happens, everyone knows with scaling industrial biotechnology that there are these things that you have to deal with?
I will say it's incredibly hard to identify the unknown unknowns, but the known unknowns. One of them is on that scale. So we've been working out of glass fermenters so far. And there's a big shift when you move into stainless steel because you can have back pressure. So one of the things that we've done more recently is gone out and bought a 7-liter stainless steel fermenter so that we can start playing around with what parameters are going to be optimal for our organism in stainless steel. And then once we have that down pat, it should scale pretty smoothly.
In the land use reduction by 99%, does that include the feedstock that is grown to put into feed the yeast? And are there any good crops that we could grow in New Zealand as that feedstock?
I'm going to be honest, I didn't do the study, so I'm not entirely sure all of the factors that were considered. Feedstock is something that's sort of widely looked at as a hurdle for this technology. And so we're lucky that a lot of people are sort of trying to address that challenge and figure out where we're going to get that from. At the end of the day, what our organism needs is protein and sugar, right? So crops that make a lot of protein and sugar, perhaps. Yeah.
Okay, we can have one more question. I'm being nice.
But that's also a little bit proprietary for us. Yeah.
Yeah, awesome presentation. Thanks. Sorry. You mentioned that you have to filter out more than the dairy industry does at the moment, at the start of the drying process. I'm curious, I'm also assuming that you filter out stuff earlier on, or you have other waste products. Is there any value that you can obtain from these waste products, or are they strictly waste?
That's an interesting question and something we should play around with. I think there's definitely potential there. And I think it would also end up being proprietary.
Cool. Thank you.
Yeah, thank you.
Awesome. Thank you so much, Kiara. That was amazing.
My pleasure. Thank you for having me.
No worries. We have pitch time. So if any of you can come up and pitch for 1 minute, maybe you want to hire someone, maybe you want a job, maybe you're working on like a new idea and want some like input from people.
Right. Hello, my name is Mike. I'm from Wing Acoustics. We've made a new kind of audio driver for loudspeakers, and we think we've got best sound in the world for little speakers and headphones. And basically, I kind of ended up being the CEO, but I'm probably better used somewhere else. So we're kind of looking for a CEO or maybe a COO or a co-CEO based on skills. You know, ideally somebody who in a dream world could help license the tech out to companies overseas or that sort of thing. But even just covering operations. So ideally somebody who's got an engineering background, moving into business admin and that sort of thing. Thank you. Also a junior who can just build things, not very glamorous.
Awesome. Thank you, Mike.
Good evening, everyone. My name's Alex, and a few years ago I was helping to recapitalize a beef farm. It was a farm that was under a lot of stress, and I came across a shocking statistic that 70% of farmers are going to retire in 10 years, and all the farmers are telling their kids not to get into farming. So we kind of need to get food somewhere. The Guardians sort of valued it, sustainable food systems like Daisy Lab, like Halter, as a $10 trillion opportunity. There's also some stats out that 75% of people are disconnected from where their food comes from. New Zealand exports most of its food and it can't produce a lot of stuff. And what we're trying to do in the gaming world is introduce people to food and food systems, and then basically take people out onto farms to experience local food production. So we're basically trying to build a whole lot of really cool stories that people can interact with in real time.
Cool. So what do you need? Do you want people to talk to you?
Yeah.
Yeah. Come talk to Alex.
Hi everyone, my name is Mikesh Patel. I started this small company called Bits for Bots about 8 years ago. So we specialize in providing a lot of 3D printing related products. And now we have access to quite a big 3D printers as well as vacuum formers and CNC routers. Since I started my journey here, if anybody wants to explore an idea and want to build a prototype, just come and talk to me. There's no price to it. Just let me know what you want to build and we'll be more than happy to help you out. So that's Bits for Bots. Cool. Thank you.
Awesome. Thank you. Might take you up on that.
Thank you. Hello, my name is James. Here I just want to introduce our company, NZFH Electronics. So we are specialized in components distributor. We have a wide range of components, including all the well-known brands, cable assembly, embedded products. So we have very intense connections in the industry, and we have our expertise, so which ensuring our customer will have the top quality components and the service. So if you are looking for a solid sourcing solution, we are here just to beyond your expectation. And we will be attending the electronics trade show next month in Sydney. So welcome to visit us at the Ross Hill Garden, 19th and 20th. We are at the booth D25. Also, we will be attending the Electronica in Germany end of this year. Welcome to us. Thank you.
We're not in AgriTech, but we are a new startup. We are in wearable devices. So basically, we're a device that women wear at night, and it tracks their temperature over a month. So you measure your temperature every day, and you can detect ovulation. So that's your fertile window. So with that, women can use it to either plan for or prevent pregnancy. So we want to go through FDA trials as well, so that we can be a medically prescribable birth control device. I think Tulfan's
Yeah, so the reason why we're kind of here, and I know we've missed out on the wearable technology talk, but we really just want to kind of figure out what engineers we need. We need someone to develop apps, so someone that's really good at software engineering, someone to actually develop the ring. Currently, we're in our prototyping phase, so we've got an engineer that works in the university that's helping us do that. So we would just be kind of looking for someone that can design the ring and have all its sensors. So if that's kind of you, and if you are really advocate towards women's health and stuff, please talk to us and see if you can come on the journey with us. Thank you.
Some sort of hardware engineer and app design.
Hey there, I'm Liam from Engender, so sort of echoing things that have been said, Kara from Daisy and Halter. We're also really passionate about improving the sustainability, the environmentally friendliness, and also the ethics of the dairy industry, as we do sex semen for, bovine insemination. At the moment, we're kind of looking to scale as well, so we're sort of more interested in people with fabrication expertise to build the machines themselves. But, all kinds of expertise are needed. We're a very multidisciplinary company, big team of really passionate people. So if that sounds like your thing, come seek me afterwards. Cheers.
Thanks, Liam.
Hello, everyone. This is Pani. I am just new to New Zealand as such. Hardly a couple of weeks I have been come here from India. So I have about close to more than 23 years of experience into hardware design, primarily into aerospace. Few of my systems are flying for A320. I was a chief engineer for cargo door control unit. So close to more than about 12 plus years I have experience into aerospace systems, into kind of power distribution systems, motor control based systems, and then engine control, cockpit displays as such. Prior to this, kind of I was trying to come to New Zealand to bring up my family as such. So I thought of I applied for New Zealand as such, and then I got a residency visa. So I'm pretty new to New Zealand. I'm looking out for a job. So kind of I'm open. I'm ready for hire. So
How do we find you?
I was just kind of browsing through LinkedIn and then got the contacts as such. I thought like it's a good event for me to get network to the people and then uh, plan to meet people. So I thought, yeah.
What was your name?
My name is Pani. Pani, you can call me Kumar. Yeah. Hope I can get someone on board who can hire me on. Thank you.
Get part of your job. Kevin, welcome.
Good evening, everyone. My name is Kevin, and I'm not actually here to talk about hirings or getting a job, to be completely honest with you. But I am here to promote our company. So I'm from Glyn High Tech Distribution. So we're an IoT distribution company, so electronic distribution company, and we can support any quantity really, large companies, startup companies, you name it. And we pride ourselves in every one of our staff being engineers, so we can definitely talk technical as well. So if you have any kind of projects that you'd like to work with, just come have a chat. And also, I have a name tag on my jacket. I'm not too sure who's...
James.
Yeah,
Brand.
no, Johan Brand. If you want, yeah, well, I'll come have a chat with you if you want this back, and we'll have a chat if you've got $1 million opportunity. And thank you very much.
Awesome. Thank you.
David Stokes. I'm based here at Outset. I work for a deep tech company here called Ternary Kinetics, and we're doing some amazing stuff with electricity and liquids and stuff. But I'm part of the family here at Outset, and so yeah, it's a fantastic facility here. There's 3 aspects to Outset. Number one is the facility. So they've got, if you need labs or workshops or anything like that, we've got facilities here that you can use. The second part is around venture, so investment and capital. So we've got a venture fund that we invest in companies. And the last one is this, the innovation or the sort of ecosystem. So we run events like this, and we have a whole bunch of people coming through here. And if you are based here, you're basically part of that community, and you can ask questions or get ideas from other people, which is really, really valuable. So if you're interested about Outset, just give me a yell. Thank you.
Thank you. Hello, I have Layla here from Cropsy, a co-founder and COO.
Hi everyone. It's really nice to see a pretty full room despite the weather. So thank you so much for coming out. So basically what we do, we help wine growers all over the world to make the best possible management decisions for their vineyards. And we do that by providing them with insights on every single vine. And there's a little bit of context for why this is important. So every vineyard and every vine in every vineyard is an asset, right? It lives for well over 20 years. It actually takes 4 years to start properly producing grapes. And you actually get around 10 bottles of wine from every plant. And the customers that we work with, they're mostly enterprises. So they've got millions, like 6-7 million vines in their vineyards. And as a grower, like not only keeping those plants alive, but actually getting good grapes out of them, the environment's constantly working against you. Climate change is just completely rewriting the rules of viticulture, but you've also got labor shortages, regulations, even crop rejection and crop loss. And so every grower, they really just want more yield to be produced at a high quality and more sustainably. But you know, how can you do that across millions of vines and thousands of hectares in the face of all of these challenges? And so this is the gap that we fill. These crops are huge, and the best that you can do is just go out, take a walk and see what's going on, right? And so that's the gap that we fill. It's the sampling, getting a way bigger understanding of what's going on these massive crops.
Cool. Could you tell me about how your product's made? Like, how does it work?
Yeah, sure. Next slide, please. Thank you. Yeah, so basically the way that we do that is we stick cameras on tractors. We work with whatever the grower has. So most of the time that's tractors, and they're doing 20 passes of the entire vineyard every year. So we're just piggybacking on that process. But sometimes you've got a harvester, like that's a grape harvester. It does more than just harvesting grapes, but also like buggies and tractors that have other implements attached to them. Like that's a trimmer there, the thing with all the nasty blades. And so each system has 2 cameras. It has a processing unit and 4G Wi-Fi connectivity and GNSS capability. And so really like the whole innovation, this was our first innovation, was the hardware itself. It's like, how do you unlock all of this information so you can provide data and insights to make better decisions without introducing any labor units into the equation, without, getting the operator who already has a job to do like do more stuff. So it works without them having to do anything. It's like on the ignition, it auto starts. And then each system collects 4 terabytes of image data per day in an 8-hour shift. So you can't send that, right? So you have to process it on board. And then you've got much more smaller manageable packets that you biff to the cloud. And then that gets sent to our grower portal where the grower can log in. And actually also very important to note, the system geotags every single asset, vine or post.
Wow.
Yeah, down to a centimeter of its real location. So when you drive past it again, that 20 passes that we're getting, it remembers every plant. And then we can build up like a patient history of every vine.
I like that term.
Yeah. And yeah, so under the hood, in under 100 milliseconds, this is what's going on. It profiles and geolocates every asset. Most of the time that's plants. That's the interesting thing, right? The vines. In the winter, you're looking at, there's no leaves. So finding dead and missing plants, it's a huge problem. They're plants that, you're putting resources into, but you're not getting anything out of them. And then in the summer, that's the most exciting stuff, is how many bunches of grapes are there, how many flowers, diseases like on the bunches and on the leaves themselves. And then, all that gets biffed to the cloud, and then the grower logs in and they see something like this. So in this example, this chart, this is an entire vineyard summary organized by blocks. And what this is telling the grower is each one of these lines is saying, okay, this is how much percentage of your block is pruned to target. And then on the right over there, that is a single leaf on a single vine that is showing a mildew symptom of disease. So that's the breadth of information that we're able to gather. It's like all the way up from an entire summary of a vineyard, all the way down to a single leaf on a single vine. And that's really what unlocks that new potential, like that was not possible before, to make really optimized decisions for your vineyard. And why is this important? Well, this information helps with early yield indication, vineyard productivity assessment, like I mentioned, dead and missing vines. You pay for them, you get nothing out of them. When do you replant? When do you redevelop the entire vineyard, right? Just rip it up, start again. Measuring and maximizing the pruning quality, and giving complete disease measurement and disease control in the vineyard.
So is that a second image there? That's like, is that each individual plant?
Yep.
Oh,
The red
wow.
ones are posts. So that's just a part of the infrastructure in the vineyard that helps keep all the rows upright and straight. But yeah, each dot is a real vine, and the color corresponds to, I think in this case, it's how many canes it has.
Oh, cool.
Yeah.
So, what has the journey looked like so far?
Well, myself, I'm a computer systems engineer. My co-founder is here somewhere, Ali. He's at the back there. Yeah, we had the idea to do something with machine vision and computer vision for horticulture while we were studying at Auckland Uni. We studied computer systems engineering together. That was in 2016. So we kind of like let the idea cook for a bit, and we finished our last year projects in 2018 for engineering, and like straight after that we just got cracking on the idea the next month. And then we actually established the company in June of the following year, so that was June 2019, which, yeah, some of you might remember as the COVID year. But so, yeah, come about a year, it took us to get to like the first MVP, which was version 5 of the hardware at that time. This was the very first vehicle-mounted one. We had a walking one. We had a bicycle one. We couldn't ride the bicycle on the vineyard because there's like massive potholes and stuff. So we ended up pushing it anyway. But this was the first vehicle mounted one. So we were like, set up a fake vine. We just cut some like plant from from the neighbors, zip tied it to the wall and pretended it was a grapevine.
Is this the one during COVID?
I guess so, yeah.
It seems very COVID-y.
Yeah, yeah. And then we installed it on our first tractors. So at this time as well, we had quite a few prospects, like 5 or 6 prospects for trial partners, potential customers. And we were really tossing up, like, do we get them to cover the costs? Because this is not cheap. Like we were using our savings, we were using COVID subsidies to R&D loan to build this stuff. And in the end, we decided, like, okay, let's ask for them to cover the costs of the hardware, and that really shrunk the pool down from 5 or 6 to just 1. And that was our first and still to this day longest standing customer, Pernod Ricard winemakers. So that was in Blenheim. And these ran for a year, which was great, but they were plagued with problems. Most of them ended up with a pool of water like 2 inches thick. Some of them still worked too, which was quite amazing, but some of them didn't. But like that's the best way to find out, if your thing's going to stand up to the test. See how people use it, see what happens. It regularly gets driven into posts and such, and so yeah. And today we have 36 of these systems, not version 5s, version 7s, around the world in 3 different countries: New Zealand, the US, and France. Across 7 enterprise customers. They're all vineyards. We only do vineyards. We support 10 different vehicle brands, so they're mostly tractors, but some are buggies, trucks, these robots that are made by Smart Machine. If you might have heard them, they won the high-tech award on the weekend. And we've scanned 8 million unique grapevines. Yeah, the biggest challenge for us was raising capital, for sure. So we started in 2019. The COVID completely rattled the world, but at that time it was the thing that like kept us alive, because we got all the different R&D subsidies and the R&D loan from Callahan. And then at that time, like, nobody liked hardware. It was like the opposite of trendy. It was not cool. It was very difficult to find investors who were interested in the idea of it and how capital intensive it is. I think it's a different story today, but those investors do exist, and I think there's one of them here, Byron from NZGCP, like Angel Investors Marlborough, woo! Seraph Group in the US, that was our second round. So we like tried 3 times and failed 3 times to raise capital, but in 21 was when we landed the first one. And it's just a mishmash of trying to get the hardware to work, trying to expand the sales, trying to service it. We only have 9 people on our team doing all of this stuff. So, we were pretty low-key about who we worked with as well, as customers. Because you have to think, like, sure, you could build maybe 100 of these. It's not the easiest thing, but you could. Who's going to, go out and fix it when it breaks, when it's got a pool of water in it, when it like falls off, when it gets run over by a thing that does not even have tires? These are steel tracks, So, durability also is a big challenge. Also, in our case in particular, right, the user is like, the operator, is not the end user. So there's a whole chain of people involved who interact with your product that you need to consider, right? They're going to affect how you design your product. In our case, the operator finds it annoying, so they unplug it. And then the viticulturist is expecting there to be data on the front end, and there's nothing. So,
Last question. Second to last. What are you kind of pushing towards now? Like, what's like the end goal?
That's it. That's it. The big push for us this year is getting as many Cropsy boxes out there. Sales. It's sales. in these countries.
Cool. And last of all, is there anything that you need from the audience tonight?
Please follow us on LinkedIn. We post very regularly about all of the weird and wonderful things we've discovered in vineyards over the last 4 years that we've been in the field. You can see our website. If you have wine grower friends, they want to know about us. I know they do. Tell them.
Awesome. Thank you.
Thank you.
If you have your phone on you, you should go follow them on LinkedIn right now. I'm
Read
watching
our
you.
posts too. They are very interesting.
Okay, now we're
I write
gonna.
them myself.
Okay, now let's open the floor to questions. Who's up first? Here you go, Josh.
Hi, I really enjoyed the talk. Very impressed. Sounds like it wasn't that long out of uni that you guys got to like companying and capital raising. What would you have done differently in your approaching investors, I guess?
Well, quite a few things. I think it really did take us a long time to learn what the investors were looking for. So being engineers, right, we know the tech in and out. And that's what we always talk about. We always front with that. But the questions around, well, how big is your market? Like, who are you going to sell it to? How are you going to sell it? Like, is this something that, is there a business model for this that has been used before? Are you making it up, from nothing? It took us a long time to figure out, like, the questions that the investors were, had in their head that they were looking for us to answer. So I would say, like, remembering to ask them, hey, what are you looking for? Like, what are the questions I can answer for you? And building a relationship with them, because that is quite important. Like, it is like dating in a way. Like, these people are, if they give you money, they're going to be on your cap table and they're going to be very involved, and you want the right people there. And I think we do. Yeah.
Thanks.
Hope that answers your question.
My question: did you and your co-founder do your Part 4 project together?
Yes.
Oh, so that is a good foundation for building a business together.
Yeah, and a relationship.
Yeah.
Yeah.
that too.
How transferable would your tech be to other crops with similar production systems, for example, kiwi fruit?
Oh yeah, we did actually do a brief test in kiwi fruit. It was maybe 3 years ago now. As long as it's grown with a trellising system, it's a generally flat kind of canopy. It could be side facing, or it could be like horizontal offset from the ground. You could position the camera, from like this upwards. And also, like, that's the first thing, which is, I'd say, less of a challenge. It's more about the domain expertise, right? Like, kiwi fruit has, different problems, different things that the grower is looking to identify. In our case, the test we did was we built a basic kiwi fruit counter. We did that over, I think, a weekend. But ultimately decided that we really needed to focus on a single crop, because the more that we worked, and we work very closely with the customers we have and viticulturists, the more we discovered about the opportunities that we had to, like, really improve the process there. So at the moment, we're really only focused on viticulture, but it is possible to transfer it to certain crops. Yeah.
Yeah, the thing that strikes me is the potential to reduce dependence on sprays, or to target spray into particular areas of an orchard that may need it, because a lot of the calendar spraying that's done in high value crops means there's an enormous amount of chemical going on that may not necessarily need to be there.
Yeah, you're absolutely right. That was actually one of the very first areas we were looking to work in. We developed the technology to try and interface in real time with a sprayer. Like, so you put the camera on the front and put the sprayer on the back. But ultimately, we had all this data. We thought, let's start there and open up the idea of, like, optimizing the processes that are already happening. But yeah, you're right. And I think time will tell with the way that the growers will use the information that we're giving them. There is a trust element also. Like, one of the features we have, it's on the slide actually, that we just launched in December, was that evidence images. So this one here. So this is like the map of the crop. It's kind of small, but basically you've got the block here. Each dot on the map is a vine that has a symptom of disease that the system has detected. And then if you click on it, it shows you like proof of what it saw. So yeah, there's also like an education piece and like just time with learning to, I guess, trust the technology in a way. Yeah.
Thank you.
You're welcome.
The countries that you're expanding into, so the US and France, were they picked because they're large wine producers, or is there something specific about the region, like the climate, that makes it a good fit for your product?
Yes, they're major wine regions, but also like there is the wine belt, which exists on like the northern and southern hemispheres, which is a thin band that goes across the world where the climate is just right for growing grapes. And so like, you know, all the major wine regions will be in that band of climate. Yeah.
Cool, thank you.
Hi, great presentation. Is your camera system multispectral, or are you only looking at under visible spectrum?
It's regular RGB, just visible stuff that you know, you could see with your eye.
Right.
One of the
So there's no direct illumination of what you're looking at. You're just depending on daylight.
There is, yeah. So that's a second thing. That was one of the innovations we had, was how do we bring the lab conditions in a way outdoors? So the hardware has an active lighting system, and it basically overpowers the sun at the working distance. Yeah.
Yeah. Thank you.
So it sounds, correct me if I'm wrong, the technology is supposed to be reasonably one size fits all?
For what?
So have you had to spend like much time actually integrating it with every different like vehicle, or has it kind of just dropped on quite seamlessly?
There's a bit of work, mostly around the mechanics of it. But every tractor has a battery. That's all we need. Yeah.
Sort of converse to that, is there an opportunity to embed it further in the vehicles and sort of combine with the manufacturers of grape specific vehicles to be more seamless, that you don't knock it into a post and have the operators turn it off? It's just built into the Lamborghini tractor.
I hope so. Yeah, totally. Yeah, that would. That's definitely one of the avenues of like, you know, a strategic partnership or something. But yeah, I mean, that would be really nice if it, you know, you buy a deer and it comes with this thing. You know, that'd be great. Yeah.
Cool. Thank you.
Cheers for the presentation. It's good. Would there be benefit in running it at night time instead of during the day due to the lighting?
You can run it at night, and it does run at night. It goes whenever the grower runs their operation. So often they'll start spraying at, you know, very early morning. It doesn't matter what time of day. Yeah.
Just on the France angle, do you know Jack Keys is over in France at the moment? iFarmer rep. So
I do now.
You could reach out to him to get some sales.
Thank you very much.
Okay, thank you so much for joining us, Layla.
Thank you for having me. Thanks, everyone.
About. Awesome. Thank you so much to everyone for joining us today. Like we sold out pretty quickly, and we had like a massive waiting list, so it's so great to see this much interest. Hopefully we're going to be holding a lot more events from now on. I've taken over from Elise. So we have 2 more events planned this year. There'll be details about it. So if you haven't signed up to our mailing list, you should. Yeah, so and also if you have any ideas for events, come have a chat with me, because we're pretty open to themes. Like this one, for example, is the first hardware meetup that was ever run was also an AgriTech event. So yeah, if you have anything specific that you want to hear about, or a specific company you might want to hear from, yeah, come talk to me. Awesome. Thank you so much for joining us. Thank you very much to Loon Digital, Hudson Gavin Martin, and Blackbird and Outset for sponsoring. Cool. Yeah.